Welcome to the Places Medicine podcast. I'm delighted to have Dr. Rachel Keith here today from the University of Louisville. Just stepping back, Places Medicine is a podcast that's about how the environment we live in, our homes, our neighborhoods, influence our health. And they can either detract from it or they can improve it. And so, what are the things that we need to consider, to look at, and to be really excited about? So, Dr. Rachel Keith is joining me from Louisville, Kentucky. She is the Associate Professor of Medicine and the Director of Environmental Health, and she has a PhD in physiology and biophysics. What is really exciting about her work is she is looking at the environment and its impact on who we are from a rigorous scientific standpoint. And she is really trying to get at the how and the why of nature in some cases and what it's actually doing to our body to either improve us or, make us sick. Um, One of the things that I think is really interesting, she's just to add some more color to it, she's looking at, is it, we have things like air pollution or sunlight or water quality. And we often can get in the trap of thinking, what are the things we need to do to fix that and to improve that? But what I love about her work is she's thinking about, well, the air we breathe, it actually has amazing benefits. So again, how can we study that and understand that and incorporate that in our lives? So I'm really excited to have you here. And I think just to start, can you add a little bit more about who you are and how you got to this point along your scientific journey?
Sure. And thank you for having me because this is my favorite thing to talk about in the whole world. So it is amazing to get that opportunity. So as a scientist, I started my career as a basic scientist and then got a clinical degree to move into translational and human research, really because I was fascinated by this idea that the environment is really changing how how healthy we are, or how our bodies work. And so I've always thought the environment's important, and I've always wanted to protect nature from being a little kid, but being able to weave that back into the story of health was an opportunity that I wanted to take. And so once I stepped into the clinical arena, I really was weighed down by this idea that we're just telling people that everything is bad for them. And it becomes overwhelming, and it becomes something that you feel like you have no control over. So why would you even try to do any of these things that are healthy? And then with the research side, I really started to have the opportunity to understand that we are now asking a patient or a person to fight against a bigger picture of what the environment is individually. So, as an example, you talked about air pollution. So, the air we breathe is in urban spaces in particular is very polluted, and we have learned that that can trigger heart attacks. It can affect your risk for heart disease. It's linked to autism and Alzheimer's and obesity and diabetes, so all these chronic diseases, right? And so we're now asking a person to go change their diet, exercise more, take these medicines and pay for them when they don't necessarily have as much control over how they got there. We know that genetics are and can be very important, but genetic drift alone isn't enough to have caused these changes in rates of disease that we see now, these chronic diseases, right? Like there hasn't been a long enough period of time for genetics to really change. So what has changed? It's the environment. And the environment is impacted by societies, choices, populations, but we're asking people to take it on and take the burden of trying to improve their health. So how do we then instead use something that's impacting their health to impact it in a good way? And so being able to tease out opportunities for that so that we can help, again, populations, societies, cultures, these bigger swaths of people really focus on health has been an amazing opportunity that I've had.
And how are you doing that currently in your practice? And maybe speak a little bit about the Christina Lee Brown Institute at the university.
Right. So I am part of an organization called the Christina Lee Brown Envirome Institute. The directors are Rooney Bhatnagar, and he really was one of the pioneers of environmental cardiology. So he is one of the pioneers in environmental cardiology. So he brought together a very multidisciplinary team to start to look at how the environment, which is anything external to yourself, is how we define the environment, affects health. So I think a lot of times when people think of the environment, they think naturally jump to trees, which we do look at trees, we do look at greenness, but it's also things like physical activity, social systems. So, how much support do you have? Getting into that idea of loneliness, stressors, right? So, different things that socially may impact your health. We also look at air pollution. We look at noise, light, the foods you eat, and so starting to pull those apart in a way that can really be done scientifically and rigorously. So when you think about food, let's just talk about food systems for a minute. In the past 50 years, food systems have totally changed. And so food can be very complicated to study. And it's just an example of how complicated environmental research is. Because if you tell me you eat a carrot and I tell you you eat a carrot, are you eating the same thing? Because how it's grown, where it's grown, those sort of differences when it's picked impact the nutrition level in that carrot. So if you report you're eating a carrot and I report I'm eating a carrot, what nutrients are you getting? What nutrients am I getting? How much are you eating? How much am I eating? And so that's where the science behind this really comes in with our institute is that we want to break things down and start to understand the bits and pieces. So yes, you're eating a carrot, but what nutrients are you getting out of that? How much are you eating? So we're starting to think about dosages, quantities, things that are more what we call quantitative, right? So we can actually define it and look at differences in a very systematic statistical approach for people. And for a long time, being able to do that with environmental factors like air pollution, it's very difficult to do because even if we're living in the same area, how much pollution I'm exposed to will be different than the other 50 people around me.
Yeah, and I think that's really helpful because it's very hard to tease apart all the different factors in our environment, as you're saying, that contribute to our health. It could be the indoor air quality I have, the outdoor air quality, again, my connectivity to local institutions and how much community I have, or are there sidewalks? That's often a lot of what I talk about. Again, when people think of environmental health, you often jump to the trees or the air quality, but it is like, are there sidewalks in my community? Are there restaurants nearby? All of that impacts our health, and it's all about built environment in a really broad sense. Um, and another thing I love about what you're doing, and I, learned firsthand when I visited and learned about the Green Heart study, which I want to talk about a little bit, is the level of rigor that you're getting at. I went in thinking it was this easy solution of, oh, you just plant trees and that solves everything. And I really appreciate, though it is a lot to wrap your head around, the rigor of, well, it needs to be, what's the right tree species? What's the location? And all of those different factors. So we're getting really, really rigorous in the study, and not just what is been kind of the norm thus far of these associative studies. So if you could talk a little bit about that and then also the Green Heart Project and what that was all about.
Yeah, excellent. So I think the Green Heart Project and using that as an example is a really great way to kind of highlight the level of rigor that we think should be associated with these natural studies, right?
Yeah.
So Greenheart is the what we designed as a pragmatic clinical trial. So there was a 4 square mile boundary of our study, geographic boundary for our study. And in the center, we put over 8,000 mature trees, plus shrubs and different things in that center area. And on the outside, kind of donut shape, we left it alone. And so we were able to have very similar factors for like access to care, some of the things you mentioned, sidewalks, what sort of food systems are in place for them to find groceries. And we were able to study the impact of trees. So, in order to do that, though, trees can impact a multitude of things. People may get out and walk more. Trees are proposed to also help with something called social cohesion. So if you're outside in this natural space, are you going to run into neighbors? And then you're more connected. It can impact noise pollution. It can impact light pollution. It can impact air pollution. They also can give off certain products because they talk to each other. So how do you study something that is so multifactorial,
Just
right?
before you go on,
Uh,
and I think you might get to this later, but what do you mean by trees talking to each other? You can just
okay.
sidebar
Yeah.
on that for a quick moment.
Yeah. So trees are a very complex community. And I think that people who love trees know this, and people who maybe love trees and aren't as into the science are amazed by this. But they have a very complex communication system to let each other know if there's pests around, to protect themselves from stress. So that could be heat stress, that could be wind stress. Their roots intertwine, and there's microbial systems down there that all feed into this network of helping each other. So they give each other nutrients. They talk to each other to let them know to protect themselves, and they can fight off things like fungus and bugs with all these specific compounds. So these compounds are known as biogenic volatile organic compounds, because what it means is they can be released into the air and aerosolized so you can breathe them in. And plants, they can transmit through the air to other plants or through the soil in these systems. So the interesting thing is these volatile organic compounds are typically thought of as these more traditionally based ones that come from what we think of more toxic exposure. So that would be paints, combustion. So they're parts of air pollution, they're part of industrial pollution, they're part of indoor air pollution. But these compounds that are coming off of trees, we think are actually, even though they're volatile and they're organic compounds, we think they, based on literature and some of the things we're seeing and other people have seen, can actually really interact with us in a way that could be positive.
It's amazing. And I think afterwards, I'd love to get a list from you of, maybe some more popular books or whatnot that people can read about this. I know The Secret Life of Trees is one that I read a few years ago and it was mind-blowing. But back to the study and what you guys did. And so, you planted thousands of trees, mature trees and shrubs in one area, didn't in another, longitudinal. You looked at it over several years, socioeconomically diverse. So, how did you get,
Right.
what was the scientific rigor and what did you learn?
Right. So what we had to understand is how we planted the trees, where we planted the trees, what trees did we plant? Because a lot of the studies that came before us were using epidemiological studies. And what those type of studies do is they take data that was already collected to look at health. And they look at your residential address, and then they take something called NDVI, which is a satellite image of your environment, and they look for the color green. And so if it's green, it means it's green. And if it's not green, it means it's not like some sort of plant based greenness. And so then they said, well, people who are living around these plant based greennesses are on average more healthy in these different ways, right? Or they might walk more. They might have all those different factors we talked about that we had to look at to figure out how trees were helping. So again, we don't know what the tree was. We don't know if it was grass, and there's more information coming out now about things like grass may not be as beneficial as trees in some scenarios. So what we have to do is break it down into the individual pieces. Are the trees buffering air pollution? And what is the configuration? So if we put in lollipop trees, which are those traditional deciduous canopy trees that you think of on the side of the road that have a trunk and then a big fluffy top, are we trapping air pollution? Some studies have shown that it can hold air pollution down more at the area, the sort of heights that people breathe. But if we put in evergreens that are going to be leafed all year, and then have a canopy that go, which is the leaf itself that goes down to the ground, and then we kind of build it in a semi-porous way, so stacking different heights and at different intervals in between so that some of the air pollution can go in, and then that leaf also has a wax and it traps the air pollution so that it doesn't get to the people behind it. Is that what's causing the health effects? Or is it that these trees are buffering some of the noise on the expressway? So we have to put in air monitor sensors that look at particulates, which is what people typically think of with air pollution, which are little minuscule that you can't see with your eyes, chunks of things that come from combustion. We have to look at the gaseous components, which are some of those volatiles, ozone, nitric oxide. So some of these different gas components of air pollution, we have to put in monitors to look at light and noise. And then we have to look at the person and say, did it change your walking? Did it change what you're eating? Are you interacting with your neighborhood more? And then we have to look at the individual pieces, which is great for science because we silo stuff. But what's most important with the environment is we have to build these networks and kind of cobwebs of putting things back together, right? So if we put in trees and we think some of the effects of trees is air pollution, and we shrink that circle, and it's connected to these five other things, are those circles getting bigger or shrinking? So for example, we shrunk air pollution, we shrunk noise pollution, and we shrunk light pollution because these trees can do all that.
Mhm.
Well, now are we also growing a circle of biodiversity? So is there more bird song in the area, which is known to be a huge stress relief, right? Are we increasing these biogenic or good things we're breathing in? So as these circles shrink and these grow, can we look at how those all tug and are connected and put them back together in a bigger picture? Because when we do things in isolation, we're losing that connectivity of what is really important in the environment. So, but if you don't know the building blocks either, you don't know what's really causing that cause and effect. So if you go back to design for health, or you design for air pollution remediation, or you design for stormwater runoff, or you design to increase physical activity, you don't know what piece of that is causing that reaction.
Yeah, so you're getting down to the real mechanics of it. And just for people listening and watching, can you share a little bit about the rigor of the medical assessment? Because I was pretty mind blown of just the level of detail of what you're collecting and clipping and drawing
We,
blood and that the extensiveness of that.
so the participants in our study in this neighborhood and in other studies that we do, because we're doing studies in forests and pocket parks in urban spaces, really are the most important key to this, right? And I can't thank them enough because they go through a lot. So for this particular study in Greenheart, it is about an hour and a half worth of them answering questions. So that's things about their medical history, what they eat, what they take, um, um, how stressed are they? How much time do they spend in nature? Again, exercise, alcohol, all these different things that we know can affect health because we have to understand those pieces too. And then they come into us and they spend an hour to an hour and a half. And we look at things that you would normally think of: heart rate, blood pressure, how much you weigh, how tall are you. But we also look at some more advanced readings. So we look at something called arterial stiffness, which is how stretchy or compliant your blood vessels are. Because as you go through the day and you interact with stuff, your blood pressure is really regulated in part by how your blood vessels can react to that. So think of it as a balloon. If you have a balloon and you're pushing air into it and it can stretch and then retract, that's really healthy. If you have a PVC pipe and it doesn't stretch and you start pushing more and more into it, it creates a lot of strain on those blood vessels, which can lead to heart disease. We also look at lung function testing to see how it's affecting people's lungs. We collect hair, toenails, cheek swabs for your microbiome, blood, urine, and all these things give us information about your health and what you're really exposed to. Because we use that individual more as the exposure biomarker also, so that if my respiration rate is different and my mixture of environments I'm in is exposing me to things at work, at play, at home, I'm getting a more complete picture than using someone's stationary air monitoring that's associated with just where they live.
Yeah.
So we're really trying to get a very holistic picture of health and all the different, what we call preclinical markers. So we're not waiting for someone to have a heart attack and say that it's just the heart attack, but what things are changing inside you for good or for bad that would push you towards either a state more of healthfulness or a state more of disease.
And so what did you learn in this study?
Yeah, so one of the big findings we have released in the longitudinal piece is that people who lived in that area that where we greened. So be aware that when we greened, we put some on roadways, we put some in residents, we put some in parks. But anyone who lived in that area could come in to see us. You didn't have to have a tree on your property. So those people who came in to see us from that area, compared to that donut circle behind on the outside, had a significant reduction in something called HSCRP. So HSCRP is one of those what we call preclinical biomarkers. So it means it's kind of like a red flag for health, right? If it can be good or bad. And in this case, we reduced it so much that um, it would it is similar to what you would see with a 9-year addition to the lifespan. It also would significantly reduce heart attacks by, I think, around 20%. If I can get you those numbers, I'll look at them again. But these are changes for an entire community that just by where they live being manipulated, their health has been entirely changed for the better. We've also done some studies showing that some of these compounds are associated with your blood vessels stiffening. So the air pollution, in particular, some of these volatile organic compounds that are not coming from the trees can stiffen your blood vessel, can lead to liver issues. And so those are some of those negative health effects that we've been able to really think about with these gaseous components, which are much harder to test typically. But by using that person as the biomarker, we've been able to really move forward some of those associations. And then showing that the impact of those nature interventions could kind of reverse some of that potentially is really exciting.
It's amazing work. I want to jump, and because we could talk about that study and some of that work forever, but I want to jump now to the work you're doing around smell and what you're discovering there with various plant compounds. So if you could share a little bit about the work you're doing as part of the Institute and what you're learning, and so people listening to this could take away some of
Right.
this remarkable information about smell and health.
Yeah. So this is where I get even more excited because we're not talking about just buffering the bad stuff, right? Or just changing the bad stuff. We're talking about the fact that plants do their own thing That is amazing. So we talked about them communicating and protecting themselves from bugs and stress, right? So if we take those same compounds, which I mentioned that we were looking at the air pollution based volatiles and they were doing bad things. Well, if these are chemically similar, meaning they're in the air and we're able to breathe them in, could they do something great for us? So looking at literature, that's what we do as scientists. We first look and see if anyone else has looked at this. There were some signals that these plant-based compounds um, may be helping us. So we think they can lower blood pressure, they can lower heart rate, and in particular, they can really help with stress and inflammation. So then that's great, but which ones are doing it and how are they doing it? So that's really what I've been developing within these sort of projects. So we really feel like since you breathe these in, there's two different ways they can interact with you because these effects are systemic. They're not just, smell based or lung based. So we think there are receptors in your lung that may be triggered, causing full body, which is what that systemic word means, that full body effect. But more importantly, they do have an aroma to them or an odor and that's very slight. But your olfactory nerve, which originates in your nose and ends in your brain, can be triggered by these. And the olfactory system, I think, is highly underappreciated by clinicians, researchers, the general public, because the olfactory nerve ends in an area of the brain that really has to do with memory, emotional control, behavioral control. It can innervate the amygdala, which has to do with fear and some of the stress things. Uh, so the idea is that as we breathe these in, are they actually able to interact and cause changes in our brain that are super beneficial, that end up cascading out through our bodies through these neuroendocrine processes? And I think that to me, because it can affect immune, it can affect stress, it can affect memory. Like that's amazing that something you smell can do so much to your body.
And so, how are you studying that? I know you have a smell lab. So, can you tell us a little bit about the smell lab and what you're doing there?
Yeah, so I love getting to take people out in nature, but again, that's that complex mixture of things. So we have to take it back down to the more individual signals. So I have a lab. It is a space within our facilities. It has a special ventilation system that turns the air over a certain amount of times per minute. It's all highly regulated and controlled. And then we have a industrial-based diffuser system that we can put in individual compounds to then hook people up to all sorts of sensors, ultrasounds, heart rate variability, which a lot of people hear more and more about through your wearables for stress and things like that. And then collect all these types of biosamples that we've talked about, blood, urine, saliva, to look at stress hormones like cortisol or catecholamines. And then we can measure in their urine how big of a dose are people getting. So we can start to tease out what is this one plant compound do, right? Because when a tree gives off a smell or when a tree gives off something, it might be a mixture of individual chemicals that you're exposed to. So we can take out the chemical and say, what does this one chemical do? Is there a dose it's needed at? How long do you need to be around it to understand in really rigorous detail how the body is reacting to things. Um, so we are exposing people to individual plant compounds and we're watching their physiology change essentially. So we've been able to see heart rate variability change, we've been able to see heart rate change, stress, different self-reported indices of stress and or measurable objective measures of stress as people are exposed to these individual plant compounds.
It's amazing. Can you tell a little bit more about how you're tell I think for people to understand what are these compounds versus an essential oil? what is the distinction here, and what is the very unique thing you're doing of pulling out these extracts that is so different than me buying eucalyptus oil on Amazon?
Right. Okay, so we're going to kind of so essential oils, a lot of people use them, and they've been used for centuries, right? And there are some amazing, wonderful things about essential oils. Um, the hard thing about essential oil is when I went back talking to food systems, it's very similar for all plants. So if you buy a lavender essential oil, it has 500 chemicals in it, compounds, chemicals, 500 individual building blocks, let's call them, that make up lavender. So you think you're buying one thing, but you're actually buying this complex mixture of building blocks.
And is that because the plant of lavender has like 500 compounds, or is it because that particular brand may have pulled from many?
Right. So it is because the plant itself has that many things going on. So if they pull for many, then you have an even bigger potential mixture. But if we go back to the food system conversation we started with, how that plant grows also changes what is in that mixture, right? So if someone harvests lavender from place A and then someone else from place B and someone else from place C, even if they use the same species, so like the same plant, because there's kind of a little bit different variations of lavender, I'm assuming plant wise, um, how hot it was, how much stress that plant went through, how much water it had while it was growing will change the compounds and the ratios of that compound. So if there's one chemical in that lavender that may be very helpful, that chemical could be at 5% in one plant, 20% in one plant, and virtually non-existent in another. So if you happen to have harvested the plant where it's 20% and you get the oil from that plant, then you might be in luck, and that might be at that dose. So going back to how much does someone need, right? So that might be at the dose that actually helps you sleep. If you have that 5% plant, maybe it doesn't have enough, and or there might be another chemical compound in there that's more stimulatory or has effects that would counteract what you are looking for with that specific compound. So all of a sudden, someone thinks lavender oil does work and someone thinks lavender oil doesn't work. But it's because we haven't broken it down to those individual bits and pieces to look at what is it in lavender oil? How much do you need? What is it changing? Like, what there's different components to sleep, right? Is it interacting with the GABA receptors in your brain? Is it able to reduce the cortisol so your stress is reduced? You know, those are the very nuanced, rigorous pieces that really go to the science behind this that traditionally haven't been explored as much with some of this nature-based research, but is what we're trying to move to with our institute.
Yeah, I think if there's something I want people to take away from this, obviously a lot to take away from it, but is just how complex natural systems are. And, obviously people know that and know the complexity of human systems but it is so remarkable. I mean, when you're talking about lavender, when you're talking about the soil and the sun, that makes me think of wine, where people have such an understanding of these unique intricacies of grapes and where they're grown, and is it Bordeaux, is it California? And, translating that into the world of plants and then, what they can do physiologically for us, somewhat in the same sense of wine, but that depth. So I think it's that stepping back of, you know, not only are trees, talking to each other, but they're made up of so many different elements. And it's the science, and I have such an appreciation for the science you're doing, so we can get so smart on it so that we can use nature for benefit. Um, one question I have for you on this is, it's very much from the research I've done that Christina Lee Brown Institute, Envirome Institute is so unique in this. But why aren't people studying this necessarily? What do you think that is? And I have some answers in my head, but I'd love to get it from you too.
Yeah, so I think there's layers to that, right? I'm always a layer person. I don't think there's ever one definitive answer. I think from a science perspective, it is hard, right? It is hard. And some of the tools, either to measure uh, the outcomes, are advancing to so we can use them better now. I think I mentioned we're we're developing strategies with something called mass spectrometry to look at how the body breaks down as exposed to things. So we can use someone as a sensor. A lot of these compounds and components are really hard to capture in the air or in the body. So we haven't had the techniques to really be able to quantify exposure really well and understand to a really rigorous degree what people are being exposed to. Um, so I think the difficulty of the measures is then compounded also by the difficulty of the statistics. So I think, these ideas of neural networks and machine learning has really advanced um, these sort of studies as well, because we can start to layer. Because if you pull out one in a silo, you are really losing that complex mixture of what the environment is. And so when things go up and things go down, if you're only looking at one thing, you think it goes up, but you didn't see something else fall in the background. So you may be underappreciating the effect that you're not measuring, right? So I think being able to get more measurements and then layer them in a really complex way has really been advanced in recent years, allowing us to think about that. I also think that our understanding and thinking about when people looked at defining the genome, and then that hasn't really pushed health in the way we thought it would. We had to really step back and think about, well, if we're not able to get as much health movement with the genome, what is it? So I think the appreciation for how the environment shapes health is just reemerging. I think we had kind of lost that appreciation that maybe millennia ago was more represented in society because they were always in the environment and they didn't have these other chemical compounds and things that were being developed. I also think in some ways it has to do with what people can make money on, and natural based products cannot be patented. There are ways that people can commercialize them, but they are not going to necessarily make a company billions
Mhm.
off a patent, right? I think the economics of it have not been explored well enough, though, because if we're saving costs on healthcare, you know, that's an economic boost. If people are purchasing this and preventing having to spend money on medications and doctor visits, that's an economic boost. So I think we just haven't explored the economic potential and who the funders would be to look at that economic potential. Um, so I think there's a lot of opportunities for growth that are being opened up, and that as we continue to think about how this helps society as a whole, and also, what the commercialization opportunities are for that. I'm really hopeful that this will continue to grow and that people's public interest in health instead of disease and turning to that medical disease model will continue to push these avenues forward.
Yeah, I think that's all those layers are so clear. And I think it's true. I think people listening to this might say, well, nature, we've always known it's been beneficial. Millennia, different indigenous cultures have used different compounds. Florence Nightingale talked about the value of sunlight, and we've kind of moved away from that. So for some, it's like, well, obviously, but I think I appreciate adding the scientific rigor because then it can be more established in modern medicine, and there's more of those proof points of, well, this is why trees work. This is the exact mechanism, and we can prove that out. And then, yeah, I think the complexity is huge. This is not as easy as taking a pill. And planting trees in public right of ways involves cities, involves Department of Transportation, Department of Public Works, states, federal sometimes. And how do you justify that investment? Can you do some sort of value-based care model with the medical system to make those economics work? And we've spoken about that, but the levels of complexity here versus taking a pill is very distinct and different. I do want to just jump back to the work you're doing in the smell lab and what are the things you're discovering? Maybe it's about sleep or could some of these compounds mean I don't need to take a sleeping pill or I don't need to drink a cup of coffee? Like, what's the depth? What are you learning in this?
Right. So I mentioned a couple, little findings in passing earlier, but I think one of the most amazing ones is about sleep. So we have been able to send some of these compounds home and put them in someone's place of residence in a diffuser. So the idea would be if you're exposed to these compounds or a mixture of compounds, could you get rid of a pill potentially? And or could you provide an alternative for people? So people take melatonin. Melatonin is known to shorten sleep latency, which is the time to sleep. People take um, other sorts of medications for sleep, and they can really affect sleep inertia, which is that feeling of grogginess you have the next day. And not a lot is really built around the efficiency or the quality of sleep. And we hear that time and time again as clinicians. So the idea is, can we take these building blocks and put them back in a way that really affects bits and pieces of health that we know and we're seeing change with? So we have been able to show that some of these compounds can really help with sleep efficiency in particular, which is not something people can typically find on the market. It can help with sleep latency. So that goes back to where the olfactory nerve innervates in the brain, like the amygdala and some of the other systems in the brain, uh, and the stress and the anxiety and the hormones that those produce can help with the latency, but it also helps with the sleep efficiency. And you don't end up with that lethargy the next day. So we are able to start to put things back. And I think people are amazed that natural compounds done with scientific rigor can have these sort of effects. So the idea is, how do we start to layer these back? So there are compounds that we know are more stimulatory, right? And so if we blend those stimulatory compounds together, could you use it in your shower in the morning, or could you have it in a plug-in in your car as you drive into work to get that energy boost without some of these other things that you have available to you in the environment, like these energy drinks that have a lot of other compounds in them that could be detrimental to health or have so much caffeine that you crash. Um, so I think the draw for me is the fact that we can start to offer people solutions that don't have as many of the side effects that we're seeing with some of these more artificially created solutions. And not that coffee is artificially created, but maybe some of the energy drinks are.
Yeah. And you, like, many researchers out there have worked on commercializing this in your own way, and you actually have some of these products for sale, and I'll include a link. And I've used the sleep one. I couldn't sleep last night, so I went up and got it and made sure I had it on my pillow. And I think it helped me go to sleep. But talk a little bit about that work, and what you think is kind of next there for you.
Right. So I have had the tremendous opportunity, like you said, to get to start to commercialize some of these, within the university and the group and by myself. So I think, we're bringing the sleep solution to market. And so there are opportunities to get that. And we're hoping that that continues to grow because I think most people, have appreciated it and used it. My kids all use it. It's something that a lot of my kids' friends use. So the next solution that is already under works is one that's really for that inflammation and stress response. And so we're putting together compounds that we believe can reduce cortisol and HRV and self-reported stress. So if we build those together, again, they work through innervation in the brain. And then those cortisol and those stress hormones, the catecholamines, start to get tamped down. What we're doing is that systemic or that whole body effect that makes you feel anxious and or contributes to long-term chronic disease is getting reduced. So these are all support mechanisms for health. And we're also, my kids really spurred this part of it. Artificial scents can really be detrimental to our health. And so we're trying to craft other products that incorporate these and have people. We go to a farmer's market with those. I think they're on the website too, but we go to a farmer's market and just start to talk to people about thinking about what you put in you, what you put on you, and that it's not just about ingestion through your mouth, what you're eating and drinking, but what you put on your skin absorbs stuff. And, if you took the compound that we're crafting for wellness and you put it on your skin on a rash, it's highly anti-inflammatory. I've used it on poison sumac. Um, and it has a different response because the receptors that it's interacting with first are different than the receptors in your nose. So if you eat something or you breathe it in or you put it on your skin, your body's going to react differently. So I just think really moving forward that idea of we have to think about our environment supporting us from a research side. We have to, as clinicians, talk to people about their environment, right? I talk to people about that in the clinic. Think about, are you using Fabuloso and burning candles that have a lot of scent and then eating a lot of ultra processed food? Like, what role does this have in your health? I still eat ultra processed food at times, like no one's perfect, but just starting to think about how the layers add up and how we can support people to make it easier. Because I really think if we change infrastructure and we change systems, then that individual burden diminishes. So the stress we have of, oh my gosh, I didn't get to the gym. Oh my gosh, I can't afford the organic, berries because they're $12 a bundle now. And my kids eat 10 bundles a week, right? Like whatever it may be that's putting stress on us as the individual, if we have healthier systems in place and we can create those, you know, what can we do? Like I think the possibilities are really exciting, honestly.
Yeah, thank you so much. I love the positivity around this, and I think moving away from from the consumer, the individual burden is so important. I think so much is put on us, especially with environment, where it's what are we purchasing, what are we, swimming in, essentially. And so I think this rigorous scientific approach, and then looking at how environmental aspects, whether it's trees or it's the volatile organic compounds coming off of trees, how that can be flipped to be beneficial for us is such a unique and better way of looking at it. So thank you so much for joining. I'll make sure the link to your product is sent out with this and is on my website and whatnot. But thank you so much for joining. I really appreciate it.
Yeah.